integrations. So through byparts, how we can integrate through byparts. That's we are going to learn today. Integration of f of x, g of x into dx. Formula is f of x, integration of g of x minus integration of f dash of x, integration of g of x dx whole dx. I'm going to explain which function we have to take f of x, which function we have to take g of x. After taking f of x, we have to differentiate f of x. After taking g of x, we have to integrate the g of x. If you are ready with the f dash of x and integration of g of x, then we can apply the formula f of x into g of x dx integration. It is nothing but f of x integration of g of x, f dash of x integration of g of x dx whole dx. Next we will be with the integration of this. First integration is first part will be over. Right? To move from the first problem, how we evaluate the integration. First one is, what is the integration of simple problems we can do it. Suppose log x is given. Log x is given into dx. Which function we have to take it as f of x? Which function is have to take it as f of x? Here we will follow highlight. Here highlight is inverse trigonometric function, logarithmic function, algebraic function, trigonometric function, exponential. Here I consider it as into 1. 1 is algebraic function, f. This is a logarithmic function. Among the logarithmic and algebraic function, logarithmic function is first. So we consider f of x as a log x. What is the derivative of log x? 1 by x. So first part is over. And we have to consider g of x. What we have to take g of x? G of x is 1. What is integration of g of x dx? It is x. Okay. Now we have to write the formula for the integration of f of x, g of x into dx. What is its formula? F of x integration of g of x dx minus integration of f dash of x into integration of g of x into dx whole dx. Okay, right. So just integration of log x into 1 into dx, nothing but f of x. Look here there, f of x is log x. Okay. Integration of g of x value, I write it as x. Here first part is over. Next second part of this is, second term is f dash of x. I write it as 1 by x. And then integration of g of x is x into dx. Here x gets cancelled. We must evaluate this integration now. This integration is integration of dx. I know it as x. So there is log x into x minus x plus c. So you can write it as x log x minus x plus c. Right? So this is the method of doing integration. Right? So next we will go from the next one. Second problem. Look here. Same problem. Integration of x log x. And now you have to give me the value of f of x. So what is f of x? F of x, I consider it as log x itself. That is logarithmic function. Next one, g of x as x. The derivative of f of x, it is logarithmic. Highlight no? Highlight. Algebraic function, first logarithmic function, then algebraic. Okay. So inverse is not there, trigonometric is not there, and exponential is not there. So these two functions are there. Among them, logarithmic is first. So f dash of x is equal to 1 by x. What is integration of g of x dx? Is x square by 2. Now come here. We have to apply the formula. I write every time so that it gets by hearted when you just look into the monitor. Write the f of x integration of g of x dx minus integration of f dash of x into integration of g of x into dx whole dx. Right. Integration of, I write it as log x, f of x is log x and x is the g of x dx. This is f of x is log x. Look here, look these things and then write the values. G of x is x square by 2 and then minus integration of f dash of x is 1 by x, integration of g of x is x square by 2 into dx. X gets cancelled. So we have to evaluate the second part here, that is evaluate the integration. Here the integrate 1 by 2 constant and then the integration of x dx is x square by 2 plus c. So the total value is x square log x by 2 minus x square by 4 plus c. That is the value. Next, look here, integration of x power n into log x into dx. Now, how you evaluate this? I consider this, whenever you get into n, you consider this as I. I is nothing but integration of x power n log x into dx. May not be necessary if I is not, then not necessary, but if you take it, then it will be very convenient in many of the cases. So what is it? F of x? Here the logarithmic function is given, I consider it as first function, so its derivative is 1 by x. Here g of x is x power n and integration of g of x dx is x power n plus 1 by n plus 1. Don't write c till the integration is completed. So I can write I as, I is a log x into x power n. So formula is f of x, integration of g of x dx minus integration of f dash of x, integration g of x dx whole dx. Right, what is the value of f of x? There is log x. What is integration of g of x? That is x power n plus 1 by n plus 1 and then minus integration of 1 by x into x to the power of n plus 1 by n plus 1 into dx. X gets cancelled. So here we write the value x to the power of n plus 1 by n plus 1 log x minus 1 by n plus 1 taken out. Remaining part is integration of x power n into dx. Again integration of x power n is x power n plus 1 by n plus 1 plus c. So this can be written as x to the power of n plus 1 log x by n plus 1. You must learn it as a formula in objective. X to the power of n plus 1 by n plus 1 whole square plus someone others will write it as x power n plus 1 into log x power n plus 1 by n plus 1 log x minus 1 by n plus 1 plus c also. Right. Next we go for the next one. X power 5 log x, you can do it as homework. X power 2 into log x, you can do it as homework. And then integration of 1 by x square log x. I'm explaining all the logarithm functions here. So here clearly 1 by x square is also algebraic function. So f of x is equal to log x. What is f dash of x? F dash of x is 1 by x. What is g of x? G of x is 1 by x square, isn't it? G of x is 1 by x square. What is integration of g of x dx? There is integration of 1 by x square is minus 1 by x. Derivative of 1 by x is minus 1 by x square. So here integration of g of x dx is minus 1 by x. Now what is the integration formula? Integration of f of x into g of x into dx is equal to f of x integration of g of x dx minus integration of f dash of x integration of g of x dx, then a whole dx is the formula. Now I consider this as integration of log x is f of x, 1 by x square is g of x into dx. What is f of x? That is log x. What is integration of g of x? That is minus 1 by x minus integration of derivative of log x minus 1 by x into dx. Now the formula is minus log x by x plus integration of 1 by x square is again minus 1 by x. Integration of 1 by x square is minus 1 by x plus. So answer is minus log x by x minus 1 by x plus c. Okay. Right. Now we move on to next method of this, integration of sine inverse of x. Integration of sine inverse of x. What is integration of sine inverse of x? Here inverse of trigonometric function is given, isolate, and then one is not there. So isolate, inverse is there, and the one I consider it as algebraic function. So I can consider f of x as sine inverse of x. Its derivative is, you must learn the derivatives. Here the derivative is 1 by root of 1 minus x square. G of x is equal to 1, and then integration of g of x dx value is x. So now come here, I apply the formula for the sine inverse of x into 1 into dx as, now directly I write in the value, since you know in the formula, f of x integration of g of x minus integration of 1 by root of 1 minus x square dot dash of x into x into dx. This can be written as x into sine inverse of x. When I go here within the plus, integration of multiply with 2 minus 2x. Here I wrote plus, so minus is sent inside, minus x, multiply and divide with 2 minus 2x by root of 1 minus x square into dx. So if you consider this as f of x, its derivative is here. So this is x sine inverse of x plus 1 by 2 into 1 by root x into dx. 1 by root of f of x into d of f of x is 2 root x. So there is 2 root of 1 minus x square plus c. So 2 gets cancelled. So remaining x sine inverse of x. X sine inverse of x. Here, what is the function means? F of x is the inverse trigonometric function. In isolate, we are taking sine inverse of x first. So what is f dash of x means? 1 by root of 1 minus x square. What is g of x? G of x is equal to x. So integration of g of x dx is nothing but x square by 2. So now we go for the formula. What is formula? Integration of f of x g of x into dx is nothing but integration of f of x integration of g of x dx minus integration of f dash of x integration of g of x dx whole dx. Now substitute in it, integration of sine inverse of x is f of x is integrate g of x into dx. Yes, f of x, we'll write it as sine inverse of x, g of x as x minus integration of f dash of x is 1 by root of 1 minus x square into g of x dx is x square by 2. In first integration, we have discussed how to integrate x by root of 1 minus x square by root of 1 minus x square, and x cubed by root of 1 minus x square. So, since we know it, it is the x sine inverse of x minus 1 by 2 into integration of x square by root of 1 minus x square. So, the method to solve this integration, evaluate is See that x square coefficient is negative. So I write plus here and take minus here. Add and subtract 1. Add and subtract 1. There is minus 1. So right. X into sine inverse of x plus 1 by 2 into integration is root of 1 minus x square dx minus 1 by 2 into integration of 1 by root of 1 minus x square into dx. So the value is x into sine inverse of x, 1 by 2 into formula for this, and then minus 1 by 2 into 1 by root of 1 minus x square is sine inverse of x. So what is the integration of root of 1 minus x square? Formula is x by 2 root of 1 minus x square plus a square by 2 sine inverse of x. So x sine inverse of x is one term. Next one is x by 4 root of 1 minus x is second term. And third term is 1 by 4 sine inverse of x. And the last term is 1 by 2 sine inverse of x. If you just simplify, you'll get x sine inverse of x plus value of this is plus 1 by 4 minus 1 by 2 is minus 1 by 4 sine inverse of x plus c, and the middle term is x by 4 root of 1 minus x square. I wrote this as it is, and the simplification term here 1 by 4 into sine inverse of x plus, right? What is the integration of, similarly, what is the integration of cos inverse of x? Cos inverse of x into dx. We consider f of x as cos inverse of x and g of x as 1. What is f dash of x? Minus 1 by root of 1 minus x square, and g of x is 1. So if you apply the formula, f of x is cos inverse of x. Integration of g of x is x. Integration of g of x is x. So minus f dash of x minus 1 by root of 1 minus x square into g of x dx is x into dx. So there is x cos inverse of x plus x by integration of x by, else you can write this as minus itself, this as minus root of 1 minus x square. Under root, if you differentiate, it becomes minus 2x. So multiply and divide with 2 into dx. So there is x cos inverse of x minus 1 by 2 into integration of f dash of x by root of f of x formula is 2 root of f of x. So I can write it as 2 root of f of x is 1 minus x square plus, here minus will be there. Derivative of this is minus 2x. So 2 gets cancelled. That is cos inverse of x. If you go for x cos inverse of x, you'll find another important thing, integration of x cos inverse of x dx. What you consider, f of x as cos inverse of x and g of x as x. I here, a here. In I is inverse trigonometric function. First I have taken this as f of x, algebraic function as g of x. So its f dash of x is minus 1 by root of 1 minus x square, and its integration is x square by 2. Now if you go for the formula, I is equal to, if you consider this as this I is equal to f of x integration of g of x minus integration of f dash of x. Integration of g of x is x square by 2 into dx. So there is x square by 2 cos inverse of x minus 1 by 2 into integration of minus x square by root of 1 minus x square. You add and subtract minus 1. So that the first integration, this is x square by 2 cos inverse of x minus 1 by 2 into integration of root of 1 minus x square into dx plus 1 by 2 into integration of 1 by root of 1 minus x square into dx. This becomes x square by 2 cos inverse of x minus 1 by 2 into formula x by 2 root of 1 minus x square plus 1 by 2 x square a square by 2 sin inverse of x plus 1 by 2 into sin inverse of x. This can be written as minus cos inverse of x also. So this I can be written as x square by 2 cos inverse of x minus x by 4 root of 1 minus x square. This becomes minus 1 by 4 plus 1 by 2 is plus 1 by 4 sin inverse of x plus c. Right. What is the integration of tan inverse of x? What is integration of tan inverse? So here we consider f of x as tan inverse of x as that of the previous problem and g of x as 1. Here what is f dash of x means 1 by 1 plus x square is f dash of x. Integration of g of x dx is x. So if you consider the formula I is equal to integration of f of x into g of x into dx is equal to f of x integration of g of x dx minus integration of f dash of x into integration of g of x dx into whole dx, right? So if you take this as I as tan inverse of x into 1. So I can be written as f of x, that is tan inverse of x, and then g of x as x minus integration of 1 by 1 plus x square into x into dx. So this is x tan inverse of x minus, if you multiply and divide with the 2, this becomes integration of f dash of x by f of x. The x is nothing but log of f of x formula. So this becomes 1 by 2 into log of 1 plus x square plus c. So there is the integration of tan inverse of x. Integration of tan inverse of x. Integration of x tan inverse of x. Integration of x tan inverse of x. Next problem. So here you consider f of x as tan inverse of x. Its derivative becomes 1 by 1 plus x square. What is g of x? It is x. What is the integration of g of x? It becomes x square by 2. So this integration can be written as integration of tan inverse of x into dx is equal to f of x is tan inverse of x, integration of g of x, x square by 2, minus integration of f dash of x is 1 by 1 plus x square into integration of g of x into dx. Now this integration can be written as x square by 2 tan inverse of x minus 1 by 2 into integration of, look here, x square by 1 plus x square. What I have to do is add 1 and then subtract 1 into dx. Same method. X square by 2 tan inverse of x done minus 1 by 2 into, split this into two integrations. That is the integration of 1 minus 1 by 1 plus x square into dx. So you can write the formula now. X square by 2 tan inverse of x minus 1 by 2 into integration of 1 is 1 by 2 into x minus or minus plus integration of 1 by 1 plus x square is tan inverse of x plus there is the integration of x tan inverse of x. Integration of x tan inverse of x. Next we go for the problem integration of tan inverse of x by x square. Tan inverse of x by x square into dx. What we consider? 1 by x square is algebraic function. Tan inverse of x is inverse trigonometric function. So I can say f of x as tan inverse of x, f dash of x is 1 by 1 plus x square, and then g of x as 1 by x square, and then integration of g of x dx is minus 1 by x. So this integration of tan inverse of x into 1 by x square into dx is equal to f of x is tan inverse of x, integration of g of x is minus 1 by x, minus integration of f dash of x is 1 by 1 plus x square into minus 1 by x into dx. This becomes 1 minus tan inverse of x by x, and then plus integration of, I split it into partial fraction through trial and error method. First one is, I consider it as 1 by x, and this as 1 plus x square. If we take this here, 1 plus x square minus x square becomes 1 by x into 1 plus x square. You can check now. If you take LCM, x into 1 plus x square, 1 plus x square minus x square is 1. So that is nothing but 1 by x into 1 plus x square. You apply the trick, certainly in examination also you can write this. So minus tan inverse of x by x plus integration of 1 by x, we know the value of integration of 1 by x into dx, minus 1 by 2 into integration of 2x by 1 plus x square. I separated the integrations. I split it into two integrations. Multiply and divide with the 2 for the second integration. So that we'll get a tan inverse of x by x, and then plus log x minus 1 by 2 into formula for integration of 1 by f of x into f dash of x, or f dash of x by f of x into dx is equal to log of f of x. So I can write it as a log of 1 plus x square plus c. Okay. Here the integration of root of a square minus x square into dx. How you evaluate this? Here I consider this as I. Let us consider f of x as root of a square minus x square. Next integration is not there, next function is not there, so I consider it as 1. Its derivative is f dash of x is 1 by 2 into root of a square minus x square into minus 2x. Integration of g of x dx is x. So I consider this as I. I is nothing but integration of root of a square minus x square 1 into dx. Formula is f of x. Integration of g of x dx minus integration of f dash of x integration of g of x dx whole dx. So this integration can be written as f of x is root of a square minus x square, g of x is x minus integration of f dash of x is, I can write in the f dash of x as a minus x by root of a square minus x square into x into dx. And now, so what is I? I is nothing but the integration of this. So this I can be written as x into root of a square minus x square, then minus integration of x square by root of a square minus x square. So minus. So add and subtract a square. Add and subtract a square. Added a and subtracted a into dx. This is nothing but x into root of a square minus x square minus, I can write this as a by root a is nothing but root of, that is root of a square minus x square plus minus of minus plus a square into integration of 1 by root of a square minus x square. This is also I. This is I. This is also I. So I can write it as 2I is equal to x into root of a square minus x square plus a square into formula of this is sin inverse of x by 1 by root of a square minus x square formula is sin inverse. So what I can write is I is equal to x by 2 root of a square minus x square plus a square by 2 sin inverse of x by plus, right? Next one, similarly we have to prove this integration of root of a square plus x square. These are the problems given in exam. So consider f of x as root of a square plus x square. What is f dash of x? It is 1 by 2 root of a square plus x square into 2x. Gets cancelled. G of x is 1. Integration of g of x is x. Same method. You consider this as I. So I can write the formula now for I as, what is I? F of x, that is root of a square plus x square. Integration of g of x as x minus integration of f dash of x is x by root of a square plus x square, and then integration of g of x is x into dx. Now this is x into root of a square plus x square minus integration of x square by root of a square plus x square. So add a square and then subtract a square. For the first two terms, you separate this integration into two terms. There is nothing but x into root of a square plus x square minus integration of root of a square plus x square. A by a is root of minus of minus plus a square into integration of 1 by root of a square plus x square into dx. Since you consider this as I, this is also I. If you take this to this side, this becomes 2I. 2I is equal to x into root of a square plus x square plus a square into formula for it is sin h inverse of x by a. So what is the value of I now? I is integration of root of a square plus x square is x by 2. Same root of a square plus x square plus a square by 2 sin h inverse of x by a plus. Similarly, we can do the problem for this integration of root of x square minus a square into dx. You consider f of x, right? F of x is equal to root of x square minus a square. F dash of x is 1 by 2 into root of x square minus a square into 2x. 2 gets cancelled. G of x as 1, and then integration of g of x dx is x. If you consider this as I, I apply for byparts. Byparts is f of x, g of x, integration of g of x minus integration of f dash of x is x by root of x square minus a square. G of x is x into dx. Now I can write it as x into root of x square plus minus a square minus integration of x square by root of x square minus a square. Add minus a square and then a square. Now first two terms you split into two integrations. This is x into root of x square minus a square, then minus integration of a by root a is root a, that is root of x square minus a square, which is nothing but I, and then minus of plus is minus integration of a square by root of x square minus a square into dx. So for this I can write it as 2i. If you get this to this side, it becomes 2i. Remaining is x into root of x square minus a square minus a square into formula for this is cos h inverse x by a, and therefore I is equal to x by 2 into root of x square minus a square minus a square by 2 cos h inverse x by a plus c. Integration of e power ax sin of bx plus c. E power ax sin of bx plus c, I consider this as I. So what is f of x? F of x is, you consider it as sin of e power ax itself. What is f dash of x? A into e power ax. Or else you can consider f of x as sin of bx plus c also. Both are irreducible functions. So a into e power ax. G of x as sin of bx plus c. I violated from the rule I left. Even then I will get it, since both are irreducible functions. So g of x is minus cos of bx plus c. Okay. Now what I get, I is f of x integration of g of x dx minus integration of f dash of x integration of g of x dx whole dx. Right. So this integration I can be written as f of x is e power ax, and g of x is integration of g of x is minus cos of bx plus c by b. I left b here, and then minus integration of f dash of x is a into e power ax. Integration of this is minus cos of bx plus c by b into dx. So I is minus e power ax by b cos of bx plus c minus of minus plus a by b into integration of e power ax cos of bx plus c into dx. Now we go for the again integration. For this again I apply Byparts. Look here, for this Byparts, I directly do Byparts for this. Minus e power ax by b cos of bx plus c, and then plus a by b into e power ax as f of x. Integration of cos of bx plus c is a sin of bx plus c by b. Okay, right, minus integration of f dash of x is a e power ax, and then integration of this is sin of bx plus c by b into dx. So now the integration can be written as minus e power ax by b cos of bx plus c plus a by b square e power ax sin of bx plus c, and then minus, if you multiply this with a by b, you will get minus a square by b square into I. A square by b square into I. So this integration, if you get this to this side, I, if you get common, if I is taken common, you will get 1 plus a square by b square is equal to, take e power ax common, e power ax by b square common, so that when you multiply and divide with b, this becomes minus b cos bx plus c plus a into sin of bx plus c. So this implies I is I into b square plus a square by b square is nothing but e power ax by b square into a sin bx plus c minus b cos bx plus c. So I can end the problem like this. I is nothing but e power ax by a square plus b square and then into a sin bx plus c plus b cos bx plus c plus some integration constant. Right. So go for the same type of problem, integration of e power ax cos of bx plus c. How we integrate this? Here I can write directly so that you can understand this. F of x, integration of cos x is sin of bx plus c by b. If you cultivate this habit, then it becomes very easy to understand the things and to work out the problems without irritation. Minus integration of derivative of e power ax is a into e power ax and then integration. Same value I have to write here, sin of bx plus c by b into dx. Right? So this is, if you consider this as I, then this becomes I is equal to e power ax by b sin of bx plus c minus a by b into integration of e power ax sin of bx plus c. Now again apply Byparts for this. Again apply Byparts, e power ax by b sin of bx plus c and then minus a by b. Now formula for Byparts, e power ax is f of x, integration of sin of bx plus c minus integration of e power ax into derivative is a, e power ax into f dash of x, integration of sin of bx plus c dx whole dx, that is. Right. So here it is e power ax by b sin of bx plus c, right, bx plus c minus a by b into e power ax sin of bx plus c integration is minus cos of bx plus c by b. Okay, and then multiply this with this, minus of minus a by b into e power ax into a, integration of this is minus cos bx plus c by b into dx. So value is I is equal to e power ax by b sin of bx plus c minus of minus plus a square by b, a by b square, a by b square, there is a by b square, e power minus of minus is plus e power ax cos of bx plus c and then minus a square by b square into I. E power ax cos of bx plus c is I minus, get outside, a by b minus of a by b, if you cut common, it multiplied with a by b and it becomes minus a square. Right, if you take I common, you get into 1 plus a square by b square is equal to e power ax by b square. If you take common, it becomes b sin bx plus c plus a cos bx plus c. There it becomes a cos bx plus c. Write like this. Right. This becomes plus a cos bx plus c. Right. Then if you take LCM, this becomes I is equal to e power ax a square plus b square. B square, when taking LCM, this 2 gets cancelled and then sending a square plus b square to this side, you get into b sin bx plus c plus a cos bx plus c plus k, that is